Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're joining live or you're watching the recording. I just appreciate you joining me. Hello, hello. So today we're looking a module ahead, and we're getting ready to talk about module 3, which examines functions specifically. So we're going to talk about functions today and do a little bit of code to that end. So that should be pretty exciting. One of the big things about the assignments for module 3 is that we're getting into a place where what we want to be able to do is we want to be able to write code that can be modular, that we can take from one place and take it to another place, or that we can repeat multiple times and have it do the same things for us that it would otherwise. Right? And so one of the things that's going to help us with that modularity is the idea of functions, and it kind of really extends what we were talking about in Module 2, which, don't forget, Module 2 ends today. So your Module 2 assignment should be in by 11:59 p.m. today. And let's see, I kind of got off my train of thought there. It extends on what we were doing in Module 2 with variables. Insofar as, we were talking about composition and how we use variables to kind of do some composition, have some intermediate variables that hold different values for us. And functions can allow us to do some composition in some different ways. And so that's going to be part of our discussion today as we're talking about functions. So in terms of announcements, remember, Module 2 due today. I am a little behind on grading, although not much. I would have liked to have been done grading yesterday, but I've graded some of the assignments from Module 1. I haven't graded all of them yet, but they will be graded today. Probably after our live stream today, we'll go ahead and finish grading all the remaining assignments. I think I went through and looked at all the Module 1 discussion boards, which all looked great. I think I also went through and looked at all of the No, I only got started looking at the experimenting with code assignment. So that'll probably be where I pick up after live stream today and get done grading all of those. So expect Module 1 grades today, Module 2 due today. We're looking ahead in our live stream today to Module 3, which is about functions, and we're going to start talking about functions officially now. So that's the extent of the announcements here. So I'm talking about functions, and I guess the first question that we would want to ask ourselves, right, is just what exactly is a function? So a function is a named sequence of statements that performs some useful operation. Right? So when we talked about, a couple weeks ago, we defined what a statement was, a statement just being a line of code, so a sequence of statements just being a series of lines of code. So a function just allows us to take several lines of code that do one singular thing and group them together. Right? And that makes that function modular, which we'll talk more about that in just a few minutes. But our goal is to use a function to take a singular thing that's being done and just group all the statements together that do that singular thing. And so a function may take what we call arguments. You might also hear them termed as parameters. Depending on what programming language you use, they might call them something a little bit different, whether they're arguments or parameters. I've gotten to the point where I kind of use them interchangeably based on all the different programming languages I teach. So I might be calling them arguments now, and I might be calling them parameters later. But in general, when I'm talking about arguments or parameters, I'm talking about the same thing. Right? And a parameter or an argument is something that gives me the ability to take information from the outside of the function and bring it into the function. Because one of the things that we'll talk about as we kind of progress today is how a function is basically siloed. So when we take these groups of statements that do this singular thing, which is a function, and we put them inside of a function, I like to compare it to the bank. Right? If you go to the bank to do your banking, it's a very secure place, right? Like things are siloed, or programming term that we would use to that, scoped, right? Things that are created inside of the function are scoped to that function, right? So activities that go on inside the bank are to take place inside the bank, right? They don't necessarily want to have these activities take place outside of the bank because it's insecure. And so when we're dealing with functions, things that belong to a function are scoped within that function, unless we have the only way that that's not true is if we've created it elsewhere and we're bringing it into the function. And so we can do that in two ways. We can do that through arguments, as we're referring to here. It allows us to take information from outside of the function and bring it into the function. Or we can do it with global variables, which we'll talk about later on in the semester. But we can think about our argument here as like that pneumatic tube that goes from the drive-through of the bank inside of the bank. Right, I can put my business inside of that tube and send it into the function, send it into the bank. Right, that's what our parameter is doing. Is it can take information from outside and bring it in to run its processes on it. And then when it's done, we use a return to send it back out to us. We'll talk about that today as well. So why exactly do we use functions? That's a good question to ask. I mean, it might or might not be clear as you're kind of sitting there watching this why exactly we would choose to use functions. But there are several reasons. One is that creating a new function gives you the opportunity to name a group of statements. And if you're the kind of person who likes organization, you should clearly see why that's important. Right? You're basically taking a bunch of different things and you're putting it in a folder. And then you can give that folder a name, which is the name that we create when we define our function. And that makes your program easier to read. It makes your program easier to debug because everything is nice and neat and organized because you have each of the functions that do a specific thing organized with the specific lines of code that do that thing. And it all just kind of works together. Functions can also make a program smaller by eliminating repetitive code. Right? So one of the things that we've been doing so far is, we've kind of been just working line by line. And that might be one thing that we kind of do as an example today, is we kind of look at what we did maybe last week and maybe reformat it a little bit so we can use functions with parameters to be able to do things differently for us. So if you make a change later on, right, and you have to update your program, you could either write your functions in such a way where you don't have to rewrite the program, you just have to rewrite the function call, which we'll talk about in a little bit, or you just have to make very minimal changes to make your program do something completely different. Another thing here is dividing a long program into functions allows you to debug parts of a program instead of having to debug the whole thing. We talked about this a little bit last week in relation to variables, right? We said that, okay, well, if we have a long equation in a variable and we call that variable or try to print that variable out and it gives us the wrong answer, we know where to focus our efforts when we're trying to fix something. And so the process of kind of taking something big and dividing it up into smaller parts and then testing the smaller parts as we go through, we call that incremental debugging, right? Or incremental testing. So that way I can test a single function at a time. And based on that, I can know, okay, this function works, so I don't have to worry about it anymore. So if I write another function and that new function causes the program not to work, I know that the problem is isolated in the new function instead of having to look through the entire program to look for what's wrong. Right? So writing functions helps make our code easier to read, makes it easier to fix, makes it easier to deal with. Another big thing is the last one here, it's modularity. Right? If I write a good function, then I should be able to take that function and use it in another program. And it just work fine. Right? It might require some slight modification, but it's something that we can take and use from program to program to program that doesn't necessarily have to be specific to the program that we created. So that's all well and good, right? Like we've talked about now why we have to, write a new function and all that kind of fun stuff, why we would do this, what it is and why we would do this. So I guess we could start getting into the nitty-gritty of how. All right, so let's talk about creating a new function. So in Python, a function definition specifies the name of the new function and the sequence of statements that execute when the function is called. And so we have an example here, and we'll skip over to a replit here in just a minute, and we will test this out, right? And we'll see different examples of how we use things. But as we work things out here, there are several things to notice, and I have these all written down on another slide, but we're going to kind of go through them. here. So if we look at this, the first thing that we want to notice is this. The def keyword, or the define keyword. Right, so we use this keyword to help us define a function. Then after that, we include a name. And the name of our function is, or the rules that we use to name our function are basically the same as we discussed last week when we were talking about the rules to name a variable, right? We can't start it with a number, no special symbols except for underscores. If it's uppercase or lowercase in the words, when we reference it later on, it has to be uppercase or lowercase. And it can't match something that's already reserved or already in the program. Right, so the same basic rules, and I will just go ahead and warn you guys that there might be some loud noises go on during this because they are renovating the spaces behind me, the old business office, now that they've moved it down to where the bookstore area was. My new office is right beside where the old business office was, and they are renovating it to put an IT help desk into that space. So it's been loud all week, and so they might decide to start working on it again here shortly. And we're just going to put up with it. Right? I'll try to mute my mic if it gets real loud for at least the brief amount of time that it is loud, just so it doesn't hurt your ears. Well, we have our def keyword, we have our hello world, and we have this pair of parentheses here. And inside of that pair of parentheses is where we define our parameter names. So if our function doesn't have any parameters that are allowing us to bring in data from outside the function, it would be like it is here. And it would just be empty parentheses. If it did have something that was being brought into it, which we'll do examples of that, then we basically put a variable name in here. We just kind of make up a variable name that'll be specific to this function that will be converted to whatever data is being brought in when we bring the data in. The other big thing to note here is this colon right here. Because understanding how this colon works now is also going to help us in future modules when we start to work with conditionals and loops and things of that nature. Right, so when a line of code ends with a colon in Python, that means that it has other statements that belong to it. In other programming languages, we tend to take things that belong to a statement like that and wrap them in curly braces. Python does not have that structure to it. Python uses indentation to show ownership. Right, so when we see this colon here, this colon here tells us that there are more lines of code that belong to this function. And so for each line of code that belongs to this function, we indent it one level. And that indentation shows that it belongs to that function. And when we're ready to start a new function, or when we're ready to transfer out of that function, we just backspace to where our lines of text are level with the D in def again. Right, and then when we get conditionals and we get loops, they also have colons at the end of their statements, so they have lines of code that belong to them. So one of the tricky things that you'll want to pay attention to as you're kind of working in Python is that, as you're using all of these different lines of code that have other lines of code belong to them, you'll need to make sure that you are on the right indentation level for the code to work, right? Because if I had an if statement in here, it would start here because it also belongs to this function. But then the if statement has a colon at the end of it, so it has lines of code that belong to it. So any line of code that belongs to the if statement would be another indentation in. So we will get to that, right, as we... that'll become more of an issue for us as we progress and start working with other structures like our conditionals and our loops. But it is something to take note of now. Any line of code that belongs to this function needs at least one indentation to show that it belongs to another line of code. So let's look at a REPL here. Now let's write a little bit of code. The first thing, of course, that I'm going to write here is my shebang. So that is hashbang /USR /bin/env space Python 3. So now I have my shebang here, right? That's one of our best practices that we utilize when we're writing our code. Now let's write that hello world function that we saw there. Let's write it first, the way that it showed us on the slide, and then let's write it again with a parameter. Right? So as we're writing this function, we're going to create a def hello_world. Now this one we're not using parameters on, so we can leave those parentheses empty. And we put the colon there at the end of the line. And remember, the colon indicates ownership, that it has more lines of code that belong to it. So when I hit enter here, we can see that we're working with an IDE, and IDE tries to help us out. So it moves me down to the second line. But it not only moves me down to the second line, it also indents for me. Because it knows, since the previous line ended with a colon, that the next line must belong to this function. So it knows, I'm going to go ahead and indent for him. So he doesn't have to worry about it. Let's zoom in a little bit here. So you can see that a little bit better. So you can see already where my cursor is in relation to the letter D in def, that it is over a little bit. Right? We can say print hello world, as we've been doing. And so for the purposes of this function, we're done. Right? This is just a super basic function. It's the hello world in function form. This is also what we call a void or fruitless function, because we're not returning anything out of the function. Everything that's happening in the function is self-contained in the function, so it's printing from inside of the function instead of outside of the function. So I'll even do this to where I put a little comment here. That just talks about what this function is an example of. So it is void or fruitless with no arguments. So when I send you all this code, you'll have that bit of information in there as well. Now, let's try to run this code and see what happens. I know what's going to happen. But let's go ahead and try to run this code and see what happens. Nothing. Nothing happens. Right? Because it's not enough just to write a function. Another point about a function is that we have to call a function. Right? Like I said, like if we use parameters, that allows us to take data from outside of the function and bring it in. Well, if we take data from outside of the function and bring it in, we have to have a place to actually bring that data in. Or if we want to run this function multiple times, we have to have a way to be able to tell our code how many times we want to run this function. So it's not enough just to write our function. We also have to call our function. And so we call our function using the name of the function with parentheses. And so since this does not go into the function unless we're doing recursion, which is its own thing, I can backspace. So now that I've backspaced, my cursor is on the same level with the letter D in def. And I can just paste my function call in here. And again, for your purposes, I will write function call here as a comment. So you know what I'm talking about. And so now that I have this function call here, when my interpreter is reading my program, it's going to go through and it's going to see, oh, a hello world function call. I know that function. I'm going to go back and run that function. And that's when it'll print my hello world. A little bit of sawing, a little bit of sawing. Hello world, there it is. So now that we have that function call in there, it actually runs the code and does its thing, right? It's exactly what we want. So let's write this again, but let's do it a little bit differently. And let's do it as a fruitful function, or a function that returns a value. And let's bring a parameter in. Now, the way that we're going to be doing this is going to be a little weird. Right? Because it's not exactly the way that we would do it in the real world, because, you know, if we were doing something like this in the real world, it's kind of like what we were talking about last week when we were talking about, like, you know, it's kind of unrealistic because, like in the real world, we wouldn't actually format things like this. So maybe we will, let's change it up slightly, right? So I'm going to write a new function, def hello arg, A-R-G, for hello arguments, or just whatever we want to call it, right? Put my parentheses here, but this time, in here, I'm going to put name, N-A-M-E. No quotes. Or let's put username here. No quotes, right? It's not a string. It's like a variable. And it's like a variable that's used specifically for this particular function. So what I'd like to do here is I'd like this program to be able to take an argument into it and return out of it a statement that's going to say hello to whatever username is brought in via the parameter. So we'll put our colon at the end of this line. And since this is going to be a fruitful function instead of a fruitless function, we're going to write a return statement here. Return. And we'll see the difference here in just a moment. And in this return statement, I don't need parentheses after it. It's just all on one line. I can put something like hello, comma, space, plus username. So it's going to take username in. It's going to run this through a process of concatenating it with the term hello. And then it's going to return that new value that's been created back out. So let's see what happens when we call this function. And before I get too ahead of myself, let me make this comment here. This is a value or fruit full function with arguments. So now when I make my hashtag function call, it's going to be changed a little bit. We'll use hello arg. And then in the parentheses this time, I need to tell it what I want it to use as username. So maybe Mr. Ramsey. All right, so now what that's done is that's defined it as the value that is going in as username. And I can bring multiple parameters into a function. All I'd have to do would be separating them with commas here and then commas here. And as long as they're in the same order, it'll know how to map them. But it's basically going to bring in the name Mr. Ramsey, and that'll take place of the value username inside of this function. All right, whatever I define here is going to work. Now let's see what happens with this. All right, and so I'm going to zoom in over here so we can see this outer console really well. We see hello world, and then we see nothing. Right? It ran the hello world from our void function, but it didn't run, or it didn't print out this value. And you might be wondering, well, why is that? Right? And that's because a return only sends data back out. It doesn't print. Right? So if I wanted to print this, I would actually have to take this entire function call, and I could either put it in a variable and print that, which is something that I recommend doing, or you can just print it directly, right? I could print hello underscore arg, and then I could put in there, say, John Smith. Right, so when this function's called, it's going to use the value Mr. Ramsey as username. When this function is called, here on line 18, it's going to use the value John Smith as username. And so since we have this print statement here now that's dealing with this, it will actually print out the returned value. So we can run this now and we can say hello world, hello Mr. Ramsey, hello John Smith. Right, so it's just slightly different in the way that it handles the code. Right, but this part here, where we have the different names being brought in, is something that, shows kind of the power of these arguments, right? Because, for the time being, if I'm writing them in there manually, they're not really particularly useful. Right, but what if I was able to take a value from a user and put that in there? So maybe I could even ask the user for their username or for their name, and get that value back, and put it back in to the function. Now, I think that's module 4 where I actually do that, or I actually introduce the input, if I remember correctly. Or maybe we should already be doing that. Was that module 2? I don't think so. Where am I doing input? I don't even remember. Might even be module. Trying to see if I can remember, and I can't. But we can introduce the idea of input here, and if it's in a future module, then we can talk about it again. Right, so in Python, we use the input function to take input from a user. So if I wanted to create a variable, and say call this variable uname, and I could call it username if I wanted to, right? Uname, and set that equal to input. Now what happens here is that when my interpreter gets to this point in the code, it pauses for a minute. And it says, okay, I'm waiting on data. So if it sees this function call, input, it knows to stop and wait on data from the user. Now if we run this, we can see that, okay, it ran hello world, it ran hello Mr. Ramsey, it ran hello John Smith, but it didn't give me that little double greater than symbol that it normally gives when it's done. If we look here at stop, it still says stop instead of run again. It's waiting on me to type something in. Now we're not doing anything with uname yet, so this isn't going to do much for us, but we can do that. Now we can see that greater than symbol populates and it stops our program. So what that's doing is that's taking the value that the user is entering it in and storing it in this variable. Now, one of the things that you see here that might be a little confusing is the fact that, well, how would I know to enter data in? Right? How would I know? So what I need to do is I need to put a message in here that lets my user know what to do, right? So in between these parentheses here, I can put in the parameters, which basically is my message to my user. So I put a string in here that says something like enter your name, colon, and then space, because like we've talked about previously, if we want it to show up in the output, we need to put it in our input. So now I can call that hello arg function with uname, hello arg, with uname as the parameter. Put that inside of a print function. Put that whole thing as a parameter inside of a print function. So now what that will do is it'll ask the person who's using the program their name. It'll give them the opportunity to put their name in. It'll run that name value through this function and say hello to them. So it's, as we can see here, it's telling me, what is your name? Like we can zoom into that here, right? That comes from that parameter that we put inside of that input function call. And I can put something like Freddy the Yeti. And it's going to bring that value in. Whatever we put in as a value through the input function is going to come in as a string. Which there's actually a little tricksy little way that we can get around that, which is pretty cool. That I can talk about that, comes up in a future thing here. There's typecasting, and then there's another thing we can do. But Freddy the Yeti, and then it says hello to Freddy the Yeti. Right? So whatever that text is. Which is pretty cool. So I'm going to put all of this inside of a big block comment here. Triple quotes on top. Triple quotes on bottom. Just so you all have one file to use as reference. Even though as you all are practicing, I might recommend you create multiple replets to practice different things. So let's head back to our slideshow really quickly, and then we'll just cover a couple more slides here, and then we'll just do some demonstration for a little bit. Oh, forgot to turn that off. Let's get that out of here. That got a little loud, so I went mute there for a minute. Sorry about that. Oh, here it comes again. We'll just fight through it. So these are the things that we noted out of that function that we saw earlier, right? Def's the keyword that indicates the function definition. The name of that function that we saw was hello world. Right, in our replet, we created some new functions that had some different names. The rules for function names are basically the same as variable names. An empty parentheses indicates that function doesn't take any arguments. And formatting, in this case, the tabs are important. So let's move back out of this. And back over here. Now what I'd like to do is go back to the programming challenge that we worked with last week, or let's see, what was it that we did? I've taught too many classes in between that have been doing too many different things. So let's see. Last week our big demo was, I'm just going back and looking it up, we did triangle. Right, so let's do something similar, right? Let's do a cylinder today. Volume of a cylinder. And this is actually an example that I did with the Java class this past Monday. So if you're in both classes, you've seen me do an example with volume of a cylinder, but you've seen it done in Java. And you also saw it done statically without inputs. So we're going to do it with inputs here. And that's going to be something else that's going to give us some practice. So let's create a value function that takes in radius and height that will also help us get the value function And that will also allow us to move into another thing that I want to talk about during this. Because we'll start with a certain value for pi, and then we will change that value. So for those of you who don't know, which is probably most, if not all of you, to find the volume of a cylinder, it is pi radius squared h. So I want to be able to enter the radius value. I want to be able to enter the height value. I want to be able to take both of those values and put it inside or print it out to my console as the volume of a cylinder. That's what I want to do. So let's do that. So let's kind of start at the end and build backwards, right? And for the sake of time today, I won't write everything out, but I will kind of talk it out here. What I want to be able to do is I want to be able to write one function that's going to facilitate me getting my inputs. I want to be able to write another function that's going to be able to actually do the math, right? That way we have two different functions that are doing two different things. And then I'm going to want to be able to print that back out to my console. So let's start off with a function called getInput. So we'll say def get underscore input. And we're not going to need any arguments for this. Right? This is just going to be a singular function that we can kind of encapsulate all of our inputs into. So colon there, because it's a function, spaces it over. We'll make a variable called, let's say, height. And we'll set that equal to the value of input, enter height of the cylinder. Now there is a problem here. And that's that when I use this input function, everything that is typed into the console comes back as a string. And one of the things that we've learned in the past is that we can't do math with strings. So we did talk about typecasting previously, and that's one of the things that we need to do here, is I need to typecast this and bring this back as either an integer or a floating point number. So if I'm going to typecast this as an integer, I can write int here. And I can have that so then when the input comes back, it comes back as a string, but then it is automatically converted to an integer. Or another option is I can wait and typecast it later when I'm doing my function call. And so as to not kind of put a bunch of parentheses in this one statement, I'm going to wait and typecast it when I call the other function that's actually going to do my math. So we're going to create a radius variable, and we're going to set it equal to input enter radius of cylinder face. Right, so we can actually print these values to our console just to make sure this is working. So we can say print height, comma, radius. So just to make sure that we have written these lines of code correctly, we can do that temporarily. Call our function get underscore input. Run our function. Enter the height of the cylinder. Let's just enter a number, 8 and 12. And we get back 8 and 12. So we know that this is good. Those are strings right now, so we can't do math with them. We're going to typecast them later. So we know that at least these two lines of code right here are written correctly. Now what I'm going to do is I'm going to call one function from within another function. So I know I'm going to call my new function calc underscore vol for calculate volume. And then I can pass in the integer typecast value of height and the integer typecast value of radius. Now we got our little red squiggle there because calc_vol doesn't exist yet. So let's define that function. So that's a brand new function, so we're going to backspace to start ourselves a new function. And we're going to define calc_vol. Now we need to be able to take two pieces of data into this function. We know that because we're taking them in here. So I need to assign some parameters for this function. So let's assign them as h for height and r for radius. We could even use height and radius, right? Because our parameters are again scoped for our function. But just to keep things kind of easy to understand, we'll use h and r right now. And for time purposes here, we'll create a pi value. So we'll put pi here and set that equal to 3.14. And we will just print the results. So this will be, let's do some math. It is pi times radius, which in this function is represented by r squared, times height. I want to communicate to my user what this value is. So let's typecast this all into a string. And then let's concatenate that with some text that's just like units cubed. And we can even put like volume of the cylinder and concatenate that as well. Right, so now this calculation function is being called inside of this function, but this function is not being called anywhere. So in order to run this program, I need to call get underscore input. And now it'll run get input. When get input runs, it'll do the height, it'll do the radius, and then it'll call this other function, which will cause it to jump here. And run all the lines of code inside of here. So if we run that, it's going to tell me to enter a height. Let's use our same numbers as before, 8 and 12. And it'll tell us that the volume of our cylinder is 3,617.28 units cubed. Now, one of the things about this is that value of pi is pretty imprecise. So another thing that we learn about in this module are libraries, right? Specifically one library, which is the math library. So to find out more about the Python math library, and I think I have it linked in your module, but even if I don't, you can just Google Python math library. When we think about libraries, a library in a programming language is basically exactly like the library here at the school. So it has a lot of predefined things that other people have written that you can check out and use for your purposes. And we don't necessarily have all the code active in our programming language all the time, because if it doesn't need that stuff, then it's just providing us useless bulk. That's going to just bloat our program and make it run slower. Let's go into the math functions here. And we see in the math functions here, there's a lot of stuff, right? Like if you had the math functions last week, there is like a math.hypot that just does the calculation of the hypotenuse for us. There's a square root function here that would have made week 1 assignments easier instead of having to learn like, oh, it's to the half power. There are all sorts of trigonometric functions in here. And the big thing for our purpose here, and I just encourage you all to come in and read this, right? When you have some time, just kind of look through it. One of the big things as you're learning to code is, kind of reading how this stuff works and figuring it out. But one of the big points for what we're doing here is it actually has a math.py constant. So in order to use the math library, I first need to import math. So I want to go basically up to the top of my code, which in this case is just right here. And I can type import math. And now I've imported the math library into my program, just like that. Now if I wanted to, I could import a library with an alias. For example, I could say import math as M. And that gives math an alias. So whenever I refer to it later on in my code, I can refer to it as M, which is a little bit shorter, instead of math, which is 4 characters. Right? So here for pi, I can refer to the pi from the math library, which I've brought math in. If I didn't bring math in as an alias, right, if I just said import math, I would come here and write math.py. If I bring it in with an alias and say as just something else, like as M, because it's shorter, I'd go here and reference m.py, because M is math. So now I have a more precise value of pi. It's actually pi all the way out to the precision that Python can handle. So if I run this now, we should see, we'll do 8 and 12 again. And we see a lot more numbers after the floating point there. It's a much more precise value of pi. And we can take advantage of any of these functions that are being referenced here in the math library by just importing math. All we have to do is import it one time. And then making the call to the function in the other, in the library, right? So let's just do one as an example quickly. In factorial, right? A factorial is just a number where you've taken all the numbers leading up to that number and multiplied them all together. Right? So if I did 5 factorial, which is displayed in math as 5 exclamation point, I would do 5 times 4 times 3 times 2 times 1. So in this case, I've already imported math. I've imported math as M. I can print m.factorial 5, and that's going to do all the hard work for me. So if we run that now, it's going to make us do all the height of the cylinder stuff because all that's still in there. So let's just enter some values for those. And I get 120 as the result of my m.factorial 5, because that is 5 times 4. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. And I can do this with, basically as big a number as I want to. When we get too big, right, it gets huge. Because, if you think about, all those trick things where they're like, oh, what if would you like $1 million or would you like a penny doubled every day for the next Or would you, yeah, 30 days. Right, numbers get pretty big pretty quickly. So if I do something like 20 here, we see that 20 results in, after we do this, huge number. And that's 20 times 19 times 18 times 17, so on and so forth. And so we have both of those options of things to use. And I do recommend just kind of taking some time looking through this and figuring it out. And so that's a good example that brings us to our hour, where we've demonstrated the math library. We've done it twice. Once as a constant, which is just a variable value. The other as one of the functions that are in the math library. And we've practiced writing some functions. We've practiced them with parameters and without. We've practiced calling functions with parameters and without. And we did fruitless functions and fruitful functions. And that's a ton of stuff that we did today. So we'll go ahead and wrap up here. That's more than enough, right? We've hit our hour. So we'll kind of hold for questions if anybody has any questions. If you're watching this at home, right, if you're watching the recording, which, by the way, the recording is not going to come out until tomorrow because I accidentally forgot to hit the recording button, which means I'll have to wait until YouTube processes it, download it from YouTube, and then re-upload it. But it'll be okay. It'll be available first thing tomorrow, which is when our module starts anyway. But if you are watching it, if you're watching the recording and you have a question, send me an email, send me a Teams message, whatever you'd like to do there. Any questions from the people here live today? I'm not seeing any. So we'll go ahead and wrap up. I'll hang out in the chat for just a few minutes with the music playing here, just in case anybody has a last minute question. Remember, Module 2 due tonight. Module 3 starts tomorrow. If you have any questions, please let me know. Thanks for watching. We'll see you next time.
Vai cair, vai cair, vai cair, vai cair, vai cair.